Hey, good morning. Quadratic function. I tell I talk different when I do on video than when I have a whole classroom of people. So, we're going to learn about quadratics. Quadratics are basically the what? X squares. Okay? So, but first off, they're part of a polynomial function. And the definition of a polynomial function is basically this. A is a non-negative integer. Let n be non-negative such that you have any term, and that's the term one less. All the way down you get a sub 0 by real numbers such that this number is not 0, basically meaning you're going to have this. What it really means is this. You're going to have x to some power provided that the x is not what? 0. So it makes it a polynomial, and it goes all the way down to where you don't have any x's at all. They could go to basically an infinite number of exponents down. That's what a polynomial function is. Now, this is important. Degrees. It's going to come in more handy, especially a little later, maybe not this lesson, but degrees is simply this. A polynomial function, the degree will be the highest exponent, which generally speaking is usually the first term written. It doesn't have to be the first term written, but the degree is the highest exponent. So if this was like x to the 5th, and that was like an x to the 4th, x to the 3rd, x squared, the degree would have been 5. If this was an x third, the degree would be 3. Whatever the highest exponent is the degree. Okay? So this graph is a constant function. Basically, that's just a line. Notice, is there a variable x here?
No.
No. This a is a constant, hence the term what? Constant function. This one makes a horizontal line. That's just a horizontal line. Okay? This one's a linear function. Notice you have an exponent at the degree of what? 1, because there's only what? One what? X. This one has a degree of 0. Y equals, this is like y equals mx plus b. Our slope, our y-intercept, makes that linear function. And then we have the next one. A quadratic is basically one that has a what? X squared. On a quadratic, the highest degree is 2. Everybody got that? The degree is 2 on all the quadratics. All right? So that's what the definition is. So it's called a quadratic. And that was the most general type of form right there. So, what's that mean? The simplest type of quadratic function is this. Ax squared. All right, this goes back to a little library notes. So if I'm going to graph this one, if a is greater than 0, what's that mean if a is greater than 0? Really all it means is what?
Positive.
It's positive. That's it. It's a positive one. So if I have a positive graph, it's going to look something like this. The thing that will be affected will be the a. Obviously, if a is a really big number, it gets real skinny. And if it's a fraction, it's going to get what? Real fat. Technical terms would be a vertical stretch, skinny, and vertical shrink for fat. I just like skinny and fat because we understand that. We don't have to be politically correct to get in here. So, and the minimum point of this one would always be 0, 0 because it's not translated or shifted. That's going to be right there. So, domain is from negative infinity to infinity. Obviously, it's not limited, right? There's not a square root in it, and there's not a rational function, so the domain is not limited. The range on this particular one for the parent function, in a sense, where it's just y equals x squared, will be the minimum value is what? 0. Can it equal to 0? Yeah. It can equal 0, so that's why it's a bracket, and it's going to go to infinity. And the intercepts, that's actually the x-intercept and the y-intercept only occurs at the origin. And it's decreasing, where? As you read left to right, negative infinity to 0. And notice, no brackets, correct? And if it's decreasing, where's it increasing? 0 to infinity. And actually, didn't we kind of have that problem in our warm-up today?
Yes.
Yes, we did. There's a little backwards one, but all right. So that would be the quadratic function, and this one is even. It's an even function. Think about it. It only has x squared, So what would happen if you put a negative x in there? The negative times negative would still be a positive. It's also symmetric to the y. So it is an even function. All right? It has a y-axis symmetry. That's what makes it an even function. Okay? And the relative minimum or the vertex, and actually this one would actually be more than a relative. It would actually be the total what? Minimum. The vertex is the point referred to as the minimum or maximum on a quadratic equation. All right? Now what about if a is negative? How's that going to be different? It's just going to flip it, reflect it from up to down. Will the domain change?
No.
It'll be a maximum instead of a minimum. The domain will be the same. Will the range have changed?
Yes.
Yes. Notice it's not 0 to infinity, but what?
Infinity.
But it's now negative infinity to 0. You have to go from the smallest to the largest. It can equal 0, so 0 is a bracket. The intercept didn't change. Still 0, 0, the origin. It's decreasing now, and this is exactly like, it's decreasing from where? 0 to infinity. Then where's it going to be increasing? Negative infinity to 0. And this one is still a what? Even function. It does have what? Y-axis symmetry, and it's still just an x squared. All right? So, go ahead.